Hi there, and welcome to Mr. Morgan's Math Help. This is Algebra 1, Unit 2, Lesson 10, called Point the Way. I've been trying the last couple times to do the full lesson, and it's not been pretty. So I'm going to go back to what I was doing before, which is pretty much just focus on maybe a little summary of the lesson and then looking at the homework stuff. Because again, you're in high school, so you probably have some good math teachers that are teaching you the right stuff. So this gives you just a little bit of help when you're at home on your own, trying to work through the homework. So again, appreciate all the support. Thanks for coming back and watching again and again. Today's lesson really was focusing on finding patterns that are useful in writing equations for linear functions. And there's different ways to write different equations of a line. So as we go through today, you'll see again in the lesson, what you did hopefully was notice that there's lots of ways to write an equation depending on what you see. Okay, and so in this case here, we were looking at, first of all, had Zach, and Zach had written an equation. So he was looking at a pattern and looking at pattern one, you have three. I noticed two blocks are being added each time. So you notice that you're doing two there, then you're doing two more, and he kept adding there from his initial number of three. And so pattern zero would look like by subtracting two, then left one block at this is x equals zero, so I wrote b equals two in plus one. So we just made a little pattern here for what he was seeing happening overall. So Sion then said, oh, I also noticed the pattern was growing by two each time. I saw pattern one just has three blocks, and pattern two has three blocks plus two, and one block on each side. Pattern three has three blocks and two blocks. So she wrote b equals 2 times n plus 1, which is kind of what I was saying, I guess, initially was really here. She's saying you start with 3 right there, and then what is happening is you are adding 2 each time, but it's 2 minus whatever group you're in. So this is pattern number 2. So 2 minus 1, for example, is 1. So you end up with just 2. So she's looking at a different way of doing it. So Zach has one way of doing it, basically saying his x equals 0. She's saying, well, let's just start here. So different ways of writing an equation, which is kind of cool. And then Marcus jumps in and says, well, I see a different way. He says you could do this as an equation, and then there's also this as an equation. So now we have 4 ways of doing it, and we just see multiple ways of doing it. Here's another way of looking at it there as well. And so what we're seeing is that you can write an equation many different ways based upon what you see. So if I think back to some of our prior lessons, one of the things that was happening was I was coming up with an equation maybe like this, and the answer key was maybe giving an equation like this. And so I'm thinking, did I get it right? Did I get it wrong? And the only way to know is actually to take a number, like from the end, and actually plug it in and see if it works, and you end up with that solution. That's the only way to tell if it's going to be something that is equivalent or not, and that's kind of the key word there. Okay, so in your lesson today, it said use Sion's method to find an equation for each of the tables below. So again, you're looking at what they already had in place and writing an equation for each of those. And you did that. Then you can write an equation for the line, which is another method there as well. So our equations for a line, and we'll come back to that. And then for the equation of a line, it says write an equation of a line with a slope here and using a point. So if you remember our point slope form, you would say, well, you take your slope, -3, and then you do your x1, which is -1. Oh, sorry. We say our x value, which is x minus a -1, in this case here, -1. And then we add our y value, which is -5 there. And so you can make a little equation like so using the point slope form, and then another one as well. So it just kind of goes on and on, different practices here. So then we had an equation, and you want a starting point, and then find the slope and work that one out there. So this is the idea, and this is your lesson here. So in summary, this lesson you learned a new and efficient pattern for writing the equation of a line. The method can be used with a table, a graph, or any 2 points in the line. Just basically a faster way of writing an equation for a linear thing. All right, so then we had some retrieval just to practice that there, creating an explicit equation. The information of the first term is 2. Every term increases by 3. What would that be? So you work that out hopefully in class as well. Then another one with the first term is 2, and then you're increased by 3 times the previous amount. So anyways, that's the idea. And then you had some expressions just combining some like terms. So you multiply with distributive, and then you find the like terms and you get those grouped together. So that's just there. So let's take a look at the homework now. So it says make a graph of the function based on the following information, then write the explicit equation for the function. So the first one says at x equals 0, y has a value of 5. The y value decreases by 3 units each time x increases by 1. So one of the things I like to do here, just to kind of get myself set of what I'm doing, is I make a little table. It doesn't ask you to make a table, but I'm going to make one anyways. All right, so when x equals 0, y was equal to 5, and y is going to decrease by 3 minus 3 every time x increases by 1. So when x goes to 1, this is going to decrease by 3, so we end up at 2. If I was to write another point, I could say, all right, well then 2, let's decrease by 3 again, and now I'm at negative 1. And so drawing this out as a graph, I have something like this and like this. And so at 0, we're at 1, 2, 3, 4, 5. So 0, comma 5. And I'm going down. My next point is 1, comma 2. So at 1, we are at 2. And at 2, we're at negative 1. So something like that. And so in terms of my equation, I would say that f of x is equal to, well, my slope, right? We have y equals mx plus b is one equation that I could use. Again, I could also use y equals the slope times x minus x1 plus y1. Okay, and so in this case here, I'm going to use this one because I have the right numbers. So f of x equals my slope, which is negative 3, and x. And when x equals 0, that's my y-intercept. That's this point here. My b value is simply 5. Number 2, we draw our graph once again. I'll draw it here, and I'll put a line here. When x is 0, the y value is 16. So let's make these equal to 2. This will be 2, 4, 6, 8, 10, 12, 14, and 16. So when x is 0, y is 16. So that's my first little point. So 0 and 16. And the y value decreases by a factor of 1/4 every time. Okay, so we could think of that as being divided by 4. Either think of that as divided by 4 or multiplying by 1/4 each time x increases. So that's going to be going down by 1/4. When x becomes 1, we're going to multiply by 1/4. So 16, for example, times 1/4 is 16 over 4, or simply 4. And again, if we did that again by 1/4, and we did 4 times 1/4, we're at 1. So at 2, we're at 1. So just to draw a couple more points in there, I could say 1 is at 4, and at 2, we are at 1. So something like that. So we can see that it's more of an exponential type of curve. We're curving there as we go along. It's not a straight line, is it? So it helps me out knowing what my explicit equation is going to look like. We would say f of x is equal to our initial starting value of 16 times our ratio of change, which is a factor of 1/4. So we're going to say multiply by 1/4. And then we're going to say 1/4 x. And we can say x there. We can take a look and see why that is. If x is 0, kind of plug it in, just double check here, right? So if x is 0, then we would do 16 times 1/4 of 0. And when it's 0, that becomes 1. So 16 times 1 equals simply 16. So there's my x value, check. Here's my y value, check. So it matches, so that equation is going to work just fine. Okay, number 3. All right, number 3. Same kind of idea. We have a factor of 10, increasing by a factor of 10. So we're going to draw a line like here. We'll draw a line right here. Our first one is at 0, comma 1. So at 0, we're at 1 right there. So if I make myself a nice little table, we're at 0 and 1. We know we're increasing by a factor 10 times each time, which means what am I doing? I am multiplying by 10 every time. So when I go to 1, 1 times 10 is 10. When I go to 2, 10 times 10 is 100. So I have a very big jump here, right? So if I wanted to map that out and show you the whole thing, I think I should go back then and erase this line. Oops, erase that dot at least. And let's make all these equal to 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and this is 100. So at 0, I'm at 1, so somewhere way down here. At 1, I'm at 10, and at 2, I'm at 100. So I'm having this nice slope there, right? We're going to curve up once again. So in terms of my equation, we would say f of x is going to be equal to my first term. All right, what's my first term? My first term is 1. So 1. And then we're going to say it's multiplied by my ratio, which is a factor of 10, right? Times 10. And then I just put x in there to the x power. Okay, and it's the x power. I can make sure that works there for like the first one here. Do I get this if I do that one? If I put 0 in for there, that becomes a 1, and 1 times 1 is 1. If I try the next one, if I put a 1 in there, 10 to the first power is 10, times 1 is 10. That works there. And again, if I try the second one, I put a 2, 10 squared is 100, so that matches there. So we're in good shape for that equation. All right, number 4. X equals 0 and y is negative 8. So we're going to start down here. We can draw a line like so. Okay, actually let's go ahead and erase that line real quick. Let's make it a little bit higher up. So we have negative 1, 2, 3, 4, 5, 6, 7, 8. So here's our first point at 0, comma, negative 8. If you wanted to draw a little x and a y table, you can. So 0 minus 8. What's happening? We're going to increase by 2 each time. Increase by 2. Now it's not going to be, it doesn't say it's multiplying, we're just adding 2 there. So we're going to add 2. So at 1, we're going to be at negative 6. At 2, we'll be at negative 4. Okay, so we're going to have 1 is at negative 6, 2 is at negative 4, and then so on. It's just going to be there. So we can see this one's much more linear. So in terms of our equation, we would say f of x is equal to our rate of change, our kind of our slope, right? So 2 times x plus what happens when x equals 0? We're at negative 8, so minus 8. That's our y equals the slope times x plus our y-intercept, where it crosses the y-intercept at. All right, next one. Use given information to create an explicit equation. Your explicit equation should be in either slope-intercept form, y equals mx plus b, or point-slope form, y equals m times x minus x1 plus y1. Use the form that's most efficient based upon what we're given. So the first one we see we're given a slope and a y-intercept. So we would just use the slope-intercept form. So y equals negative 7, that's our slope, times x, and then plus b, it's a positive 4, so we'll say plus 4. Next one, I have a slope and the y-intercept. So y is going to equal 3/8 times x. And we could say, you could say if you wanted to, if it helps you out, you could do plus minus 3. But really that's the same as saying 3/8x minus 3. So that's the same thing, but if it helps you kind of see that you're adding that value there, that's okay too for now. All right, next one we have a slope and the y-intercept. So again, we'll do y equals our slope times x. And again, if we're going to subtract a minus 1/5, that's the same as when I subtract a negative, that's going to be adding. So if I want to rewrite that, I could say y equals 16x plus 1/5. If you wanted to. Okay, just another way of saying that one there. Oh wait, sorry. What am I thinking? We're adding this one here. We add that. I'm so sorry. I do that every once in a while, don't I? Dun, dun, dun. So we would just put that as a minus. Apologize. There we go. Next one. Now we have a point, right? So for the point, we say y equals our slope, our rate of change, times, and we're going to say, look back at our equation over here, what's it say? We're going to do our x minus x1. So we say x minus our x1, which is 0, and then we're going to add our y1, minus 7. So that's what it looks like. You could, again, rewrite that if you wanted to. If you want to see what it looks like in point slope form, you would then multiply that out. Do the next one. Y equals 2/3 times x minus our first y term, our first x term, -6. And then we're going to put our parentheses there, and then we're going to add our other term, which is 1. So again, probably good to rewrite this as y equals 2/3 times x plus 6 plus 1, just to clean up that little inside part. And finally, our last one here on number 10, on this on my paper right here, we would say y equals our slope, -5, times x minus our first x value, and then we add our first y value. Number 11, for each table, write 2 different explicit equations in point slope form. So remember, point slope form is this one right here, point slope form. So we're writing it in the form of y equals our slope times x minus x1 plus our y1, which means because we have all of these points, we can pick any one of these to write our equation. And you're going to pick 2. I'm just going to show you just one, and you could pick another one. So I'll just use the first one each time. So we would say y equals our change. We're going from 17 to 11, so we're subtracting 6 and multiplying that by x minus x1, 32, plus our y1, which is 17. And again, do the same thing, but this next one, you're going to change your x and y values. And this next one, I'll use these guys here. Y is going to equal my change. Well, 12 to 19 is what? Plus 7. Am I still plus 7 here? Yep, plus 7. So we'll say 7 times x minus my first x, which is a -54. So I could add 54, that's fine. And then we're going to add my y term, which is 12. Number 13. I'll use this one here again. And we're going to say y equals my change. 43 to 34 is what? I am subtracting 9. 34 to 25, subtracting 9. So we'll say minus 9 times x minus my first x value, 21. And I'm going to add it to my first y value, 43. For one of the tables in problems 11 to 13, show how the 2 equations you made in point slope form are equivalent. So the idea here is to take one of your problems and decide and show how they're equivalent. So let's say I did the very first one where I had -6 times x minus 32 plus 17. And my other point that was there, which I didn't do on mine, you could have said -6 times x minus 33 plus 11. To show they're equivalent, what I could do is I could distribute the -6 here, because -6x plus 192 plus 17. Combine my like terms, and I have -6x plus 209. And if I do the same thing over here, I end up with -6x, and I have a plus 198 plus 11. When I combine the like terms, I still end up with -6x plus 209. So if I take the point slope form, here and here, and I rewrite that into y-intercept like that, slope-intercept, then we see that they're equivalent. So they match and they match. All right, Ready, set, go. All right, show that the right side of the equation is equivalent to the left side. Justify each of your steps. Use the example to help you. So I'm not going to include the justification. I want you to do that, but you're going to say something like use the distributive property. You're going to say things like combine like terms. The commutative property of addition just means you're adding some stuff up. So use those kind of words for your justification, but the idea is to simply say, all right, here's my equal sign. I want to make sure that what's over here matches what's over here. So I got x minus 5 over there, so let's go ahead and use distributive property over here first. So we have 5x minus 7 plus 6x, and 2 times 1 is 2, plus 2 minus 10x. We'll use distributive property first. Now I'm going to combine my like terms. I have a 5x, a 6x, and a negative 10. 5 plus 6 is 11, minus 10 is 1x. So I can write that simply as x. And then I have a minus 7 and a positive 2, and that combined to make a minus 5. So there's x minus 5, which matches that side. So we've shown that the two sides are equivalent. All right, number 16, same idea. I want to get the right side to be equal to this, so show that it matches. So you probably want to use distributive property once again. So 24 minus 10 times 2x is 20x. Negative 10 plus times an 8 is a negative 80. And then we add the 62 and add the 7x. I'm going to combine my like terms. So let's start with our x's. We have a negative 20x, and we have a positive 7x. So that becomes negative 20 plus 7 is a combined negative 13x. And then if we take our regular numbers, 24, negative 28, positive 62, and combine all those together, we actually end up once again with the number 6. So we're going to add 6. Right? Yeah, 6. Now, that doesn't quite match, but you can notice I could shift the order around and say, let's make this 6 minus 13x. I just flip-flop those around, and now it matches great. Number 17, same idea. We can see here, distribute, distribute. So once again, we're at 2x. We're going to say adding 12x, adding 15, subtracting 13. We combine our like terms, and we have 14x, which matches that one. And then 15 minus 13 is a positive 2, or add 2, which matches that part there. And that's it for the day. Simple enough. Hopefully that was a little clearer than my last ones, and it helps you out with your homework, and you're good to go. Have a great day, and we'll see you next time.